Hello everyone. This is the second task for the Sparks internship, and in this task we have to predict using unsupervised machine learning. So, what is the task? So we have been given an iris dataset, and the task is to predict the optimum number of clusters, and we have to represent it visually. So the programming language used is Python, and the environment used is Google Colab. So now let's go to the solution part. So now since it has been done in Google Colab, so I have to import files from Google Drive. So this is the command: importing basic scientific libraries and visualizing the data. So from the data we can get an idea that the ID column itself is not unique to, or it does not form any significance. So we can ignore it since it's unique to every column. So it does not actually give us what the data is all about. So we can ignore the ID column. This is the data frame without the ID column. And now since now the species, we can say that these are the identified results from the given features. That is, like say this is iris setosa, and the given features for this species is something like this. So similarly, on that basis we can look what are the unique values. Here the unique values are 3, so most probably 3, the optimum number is going to be 3, as there are 3 unique species. And so the input are the 4 features. We are not doing much we are not going into much detail since the number of features are very low, and the number of rows are also very low. So we can go with all the features and try to identify the relationship without actually compromising with anything. So now there's a method to find the optimum number of clusters using the elbow method. So this is the command for the elbow method, and it is called the within cluster sum of squares, and we have plotted. So what will be the optimum number of clusters? From the elbow method, we can guess, since after this point, after this point, there is not much change in WCSS. So we can say this is roughly between 2 and 4, and it can be assumed to be 3. So from the elbow method also we are getting the optimum number of clusters as 3. Now we are training the k-means model, k-mean clustering algorithm, and we fit into the model, and we have now visualizing the clusters with the corresponding centroids and how the clusters visually look. So this is the final result. Thank you.